HTTP methods define the intention of an HTTP request. This was quite an interesting fact that we learned in the first part of this video covering HTTP methods. Hi, this is FK, and in this video, we'll be concluding our breakdown of HTTP methods. If this is your first time seeing our HTTP methods video, I'll advise that you go watch the first part to get a complete lesson. In that video, we looked at GET, POST, HEAD, options, and the PUT method. In this video, we'll be taking a look at the remaining standard HTTP methods. That will be connect, patch, trace, and delete. And we'll be starting this video by looking at the very first method on our list, the connect method, which is quite an interesting one. Let's assume there's someone you're currently not permitted to talk to. Let's call that person Susan. However, you need to pass a message to Susan. Luckily, you have a friend called George who has permission to talk to Susan. You can simply prepare your message and request that George helps you pass it along to Susan. Susan can then read your message, and if she has a response, she can send it back to you through George. George has simply acted as a bridge between you and Susan. And if this conversation goes on, with multiple messages being sent back and forth, George is now a channel for the two of you to communicate, even though you don't have permission to talk to Susan. This is exactly how the connect method works. If there's a server that the client is not permitted to talk to, probably due to a firewall or protocol mismatch, the client can simply call on a proxy server using the connect method. A proxy server is a server that can act on behalf of a client or another server. Let's say a client wants to connect to the servers of Facebook.com, for example, but the client is using the non-secure HTTP protocol. This client can talk to a proxy server that uses the HTTPS protocol and ask it to help communicate with Facebook.com using the connect method. The request will look something like this. Once the proxy receives this request, it will then connect to the destination server and create what is known as a tunnel between the client and the destination server. This way, the proxy server acts as a bridge between the two entities and allows data to flow freely between the two. Pretty cool, right? The connect method is primarily used to establish secure, that is HTTPS connections through a proxy server. It can also be used to bypass firewalls or access websites that are otherwise restricted. Now that we understand what the connect method is all about, let's take a look at how it stands on our methods table. First, the connect method has no request body. It simply signals the proxy server to help create a tunnel to a restricted destination. Does a successful response of this have a response body? Also no. Once the connection to the target is established, it simply returns a 200 connection established status code. It is also neither safe nor is it idempotent. It is not safe because while you can send safe requests with the GET method through the tunnel, you can also send unsafe requests using the POST method. This uncertainty makes the connect method to be considered unsafe. It is not considered idempotent because each request establishes a new connection, potentially leading to different outcomes with repeated requests. The connect method is also not cacheable and cannot be used in HTML forms. So, that's everything on the connect method. I hope you got a pretty good understanding of that one. Now, let's move on to the next method on the list, the trace method. You see, Conceptually, a request is meant to go directly from a client to a server. However, in the real world, a request passes through several other components and even other servers before it eventually gets to the target server. A simple client request to a site like x.com passes through intermediaries like proxies, firewalls, gateways, and other types of components before eventually getting to the destination server. The server or component at any of the stops the request makes has the ability to modify the request. This is often done to prepare the request to continue its journey to the target destination. At the end of the day, the message sent, while not lost, often isn't the same as what was originally sent. Some formatting could have been done, and extra data may have been added. This new form of the message that eventually gets to the destination server is not visible to the client that sent it. However, with the trace method, you can track and view it. The trace method is able to initiate what is called a diagnostic loopback at the destination server. This causes the destination server to bounce back a response with the actual message it received. This way, the client can see how its original message was modified before it finally arrived at the target. This is highly useful for tracing requests and performing diagnostic operations. It also helps you to ensure that requests are going through the request response chain as intended. It can also be great for analyzing the effects of proxies and other applications on your HTTP requests.
Hello guys, this is FK, and honestly I am tired of all the debates and arguments I'm seeing on Twitter and Reddit about which programming language is better or which framework is better. While many developers are still lacking in the understanding of how programming languages work, how databases work, how web servers work, and how even software systems work. Lack of understanding of these main fundamentals has been the reasons for things like imposter syndrome, not knowing whether you're programming the right way, or even struggling to try to be a senior developer. So, I have taken it upon myself to teach these core fundamental topics. These topics never change, and they form the bedrock of any proficient developer, DevOps, cloud, or blockchain engineer. So, if you want to get free materials and videos sent to you every week, use the link below to join our fundamentals community. I can't wait to share exciting software fundamental lectures with you as we all strive to become better software engineers.
Now that we get the gist about trace, let's take a look at how this HTTP method stands on our table. Trace has no request body. Its request structure is similar to that of a GET request. A successful response comes with a response body which contains the final form of the request message as received by the target server. Is the method safe? Of course. It is simply a diagnostic tool. Is it idempotent? Also yes. Repeating it will produce the same results without any side effects to the parties involved. Is it cacheable? Nope. And there isn't really any reason to want to cache the results. Also, it cannot be used in an HTML form. In fact, I don't think any of the methods we'll be covering in this video can be used in an HTML form. But let's confirm that by the end of this video. Our next HTTP method will be patch. Patch is a very similar method to the put method that we discussed in the last video. The intention of patch is to update a specified resource. However, unlike put that performs its update operation by replacing the entire resource with a new one, patch only updates the parts of the resource that needs to be changed. Now, this is one of those explanations that will benefit from an example. So, let's see one in action. Let's say we have this resource, which is a JSON document with a profile of John Doe. It has his email, name, and city of residence. Now let's say we would like to update the city to Los Angeles instead of New York. Let us see how put and patch will handle this update. For put, we will have to send a new JSON update that will contain the entire details, both the ones that are changing and the ones that will not change. We will simply be replacing the entire resource with a new one that contains our updated fields. Now let's look at how patch will handle this update. Instead of replacing the entire document with a new one containing the update, patch will send a document containing only the parts that need to be updated. In this case, a JSON object with only the city field with a new value. This is why some refer to patch as sending an update instruction instead of an update. It simply tells the server which parts of the specified resource to update. This allows patch to use less bandwidth than put. However, it is not as idempotent. But let's take a look at how it stands on our methods table to clearly understand its behavior. Does it have a request body? Definitely. This is where the instructions for the update or partial representation of the resource being modified goes. The successful response of a patch request may or may not have a body. It is also neither safe nor idempotent. Unlike put that guarantees you idempotency all the time, patch may not be idempotent based on the order of the request. It is cacheable if only freshness information is included in its response, and it cannot be used in an HTML form. So that's patch, another handy method for update operations. And now we are at our very last HTTP method in this two-part series, the very powerful but cautiously used delete method. Delete is quite straightforward. It simply tells the server to delete the specified resource. You point to a resource and yell delete, and the server knows it has to get rid of that resource. However, there is an interesting fact about the delete method that is really important and can even be shocking. You as the client are not guaranteed an actual deletion of the specified resource. Yeah, the server can choose not to delete it, but instead simply hide it. This is actually a rule by the HTTP 1.1 specification. It states that the server is not obligated to actually delete the resource when it receives a delete request. The server can choose to deactivate or hide the resource instead. Or, and this might surprise you, the server can choose to simply ignore the request entirely. My guess is that the server is seen here as the true owner of any resource it hosts, and it has the final say on whether the resource should continue to exist or not. The server often uses status codes to give you an idea of what actually happened with your delete request. A 200 OK indicates that the request was successful, but it does not necessarily mean that the resource was deleted. The server may have decided to process it in a different way. A 202 accepted status code tells you that the request has been accepted for processing, but the processing has not been completed. This is often used for an asynchronous deletion. And lastly, you can get a 204 no content code. This indicates that the request was successful and the server doesn't need to return any content in the response body. This code is often used when a resource is successfully deleted. While none of the status codes directly assure you that the content no longer exists, a 204 code gives the highest probability. And that's it, folks. Those are your HTTP methods. We started with get, post, head, options, and put in the previous video. And in this video, we have covered the connect, patch, trace, and delete methods. And I hope from now on, you can confidently say, I do understand HTTP methods. If you want me to do deeper dives into each method in their own videos, or have other suggestions of fundamental topics you want me to handle, feel free to write them in the comment section. Till I see you in another video, go be the best you can be.